welcome to this quick tool review. This time around we'll be reviewing some tools sent to me for evaluation from BangGood. And BangGood lets me choose out the tools I'm interested in, and I pick tools that I'm interested in and I hope my viewership is also interested in. The tools they sent me this time are ER32 collet based hexagonal profile, square profile, and rotary base mounting collet holders. So what I had in the past, which I still have of course, are the standard 5C versions of these guys, and they've always worked fine. But there are some serious limitations to 5C collets that ER series collets don't have. In a 5C collet, they cut the slits from top to almost bottom, and when you pull this collet in and it cinches the top down, it actually moves along an arc. It doesn't move straight in because it's fixed at the bottom, so you're basically moving like this, and I'm exaggerating. So even though there's an inch of profile in there, there's a half-inch collet, in actuality most of the force is right at the edge of this collet, right along this ring in a line. And there will be, because of deformation and other reasons, a little bit of force applied down the length. Most of it is right here at the end. So that means if you have a long part in your lathe, for example, and you use this in your lathe, and you're putting a lot of force on it, or you have a huge piece of stock sticking out the back, you can see, since you're just holding along a ring, the ability of the part to pivot is a little bit higher than it would be with other clamping designs like your 3-jaw or 4-jaw chuck, for example. Another feature of 5C collet is that they can have a stop inside, and this is not carried over to the ER series collets. But the ER series collets have a different feature that makes them superior in some ways. They have slots going from top to almost bottom, alternating with bottom to almost top. So what that means is that rather than just hold along the ring here with maximum force, each what you call a leaf, applies a pressure along the full length of the leaf, provided the outside is, making equal contact with the collet body. But it applies force along a line rather than right here at the end. They also, because you're not rotating around just one point, these tend to compress more equally than a 5C collet. So they have a lot more range than a 5C collet. 5C collets, you buy them in 64th increments, and you really can't go too much more than that, or the collet really will only be grabbing on this top edge. These guys have a better grabbing profile. So the ones they sent me were the 6-sided collet holder for doing nuts and things like that in your mill, the 4-sided, and the hardened and ground base plate ER32, which is designed to work on a rotary table. So what I want to do is I want to take these over to the surface plate and see if they actually hold the part down the center, because that's really what's important. Now, I'm not expecting accuracy to tenths on this, because even though they claim they're hardened and ground, this sort of thing, like if you're doing a bolt head, you're not really looking for accuracy to tenths typically. And if you are, you probably wouldn't be using a solution like this. You'd be using a measuring method of some kind rather than this. So let's head over to the surface plate and see how accurate these guys are. So here's my test setup. I've got a grinding vise, and I've mounted the 4-sided block in the grinding vise, and I have set my zero here by finding the high point by sweeping across, and I have a gauge pin, a Deltronic gauge pin, in the collet right now, and I tap it down into, tap the collet holder into the vise before I do this measurement. So first one is with the ER32 nut straight up, the laser engraving, and now we're going to pop it out, flip it 90, and see where we're at. Rotating at 90 counterclockwise, we are about 1.2 thousandths out of perfectly square. So let's flip it again, see where we're at. Then we'll be exactly opposite the starting side. Now the laser engraving is directly at the bottom, so we're measuring the how close this gauge pin is to dead center between the initial starting point, which we set at 0, and here, and we're about 0.9 inches, about I'm sorry, about 0.9 thousandths of an inch low relative to the other sides. Now we're going to flip it 90 and we can compare it against the opposite side there. The last side with the laser engraving on the right hand side here, we see that we are about, relative to its opposite side, we're about 0.7 thousandths or 7/10ths of a thousandths of an inch high or difference between dead center, and between perfect we're only off by a couple thousandths. So in worst case scenario, this thing is out of dead center by about 1.2 thousandths worst case. Better than that in the other case, or call it plus or minus 6/10ths of a thousandths. So that's pretty darn good. And to be honest, my collets were just some collets I bought on eBay inexpensively, so this ER32 collet could be the culprit here. I can't even blame the fixture. All in all, that's a pretty good turnout. Probably what I need to do is get like some Techniques collets where they guarantee they're 2/10,000ths of an inch perfectly symmetrical about center. All right, let's try the six-sided and see how it performs. An interesting point to make that will be obvious to the veteran machinist, but when I first started out, I thought I had bought an inexpensive ER32 Chinese collet, and I thought, looking at the top, oh look, they did a really poor machining job because there's a lip sticking out on one side and not on the other. But for those that weren't aware, ER32 collets are designed for the collet to snap into the top before you screw it down to the body, and I wasn't aware of that, so I thought I had gotten a faulty collet. This one looks like I might have to put a little bit of force. The last one went in easy, but this one is kind of tight. Usually you just get it off to one side and put a lip under, but this one having a problem. So was able to snap it in, so not a problem. So we will continue on here. We will put our 0.5 inch gauge pin in, and we will cinch it down, and I will set this up and bring you back. All right, so we found our 0 on the 1/2 inch gauge pin, and the laser engraving is off to the right, so now we're going to rotate it 60 degrees and see where we're at. Oh, and look at that, it just shifted on me. But when you're dealing with tenths, it really gets persnickety. Back with the first comparative side, and it is out of concentric about the center axis by about 1.2 thousandths of an inch. Next side is about 2/10ths low, and I've got to point out that in order to set this up each time, I have to rest it on the part that they machined flat, and so really what you're concerned about is these sides. But to get my height the same every time, it's resting on the point on the bottom, which has been flattened off. Amazingly enough, that's incredibly accurate as well. First opposite side is only 3 thousandths high, so I've gone around the whole thing, and it's no worse off than about 1/1000th of an inch, 1.2 thousandths, or plus or minus about 6/10ths, much like the other one, which for what the purpose of this guy is very accurate, and I am surprised it's that good, to be honest with you. So this is turning out really great. So let's go look and check out Hardness. As for Hardness, I brought my Hardness file set out again and started with the softest, the HRC40, and I scratched right up here because I didn't want to damage the other surfaces, and I could get a bite on it. So much like some of the other stuff from overseas, it certainly isn't harder than Rockwell 40, unfortunately. Final evaluation is that it would be nicer if these guys were harder, like say Rockwell 50. As far as my hardness measurements go, the HRC 40 file bites into the top just barely, so it's somewhere around 40, not as hard as I would have liked, but you know, for the price, $24.99, $27.55, and $58.91, these are a pretty darn good buy in my opinion. They were square or concentric around the center axis by no more than plus or minus 6/10ths of a thousandths, and that could be the fault of my cullet, because these are not Techniques cullets. These were an inexpensive brand, and so I don't know how perfectly round these guys are. The finish on this piece is excellent. It's very, very flat, and this guy, again, the whole point of this would be to put on a rotary table to hold a small piece up if you had to work on the end. Very handy. I give a big thumbs up for the price, and I think the quality is better than I expected, which is very nice. The nuts are very smooth, and generally no complaints other than I wish they were a little bit harder, but you can't have everything, right? If you want, go buy Royal or one of the expensive brands. Thanks for watching. Hope you find it useful. Hope to see you next time.